Okay, so today I will show you my homework chapter 9.4 to you. It's about block diagram to single flow to block diagram. Okay, so you can see the topic of this research is signal flow graph to block diagram conversion. Uh, it's a detailed experiment report and solution. Okay, so you can see the content. The first one is experiment objective. The second one is significance of the experiment. The third one is detailed solution process. And the fourth is supplementary notes. And the fifth one is conclusion and acknowledgement. Okay, so let's begin. The experiment objective. You can see understand mathematical essence, comprehend that signal flow graph and block diagram are equivalent graphical modeling tools for linear control system, representing the same input and output relationship, and grasp physical meaning, understand the roles of node, representing signals, branches, responding signal transmissions, and again in a signal flow graph, and master conversion skill. Learn to drive signal equation for from as SFG and uh, construct an equivalent block diagram. Verify their consistence through mathematical derivation, and learn and lay theoretical foundation. Prepare for more advanced system analysis technique, such as using Mason-Gain formula and simplify complex multi-loop control system. Okay, so the significance of the experiment, you can see theoretical significance depends on understanding of system modeling by highlighting the equivalence and complementary strings of SFG and block diagram, structure visualization, and the engineering significance bridge the gap between theoretical analysis and practical implementation, block diagram in MATLAB and Simulink, critical for real-world control design. Skill development hones the beta skill of translating between abstract mathematic representation and concentrate system modeling for solving complex engineering problems, and the detailed solution process. Step 1, extracting signal equation. Rules: the value of a node is equal to the sum of all incoming branch signals, where each branch signals is product of the branch gain and the signal at the source node. And you can see the equation for ES equal to XS, and the equation for C, uh, CS equal to GSES plus NS minus HS CS, and the equation for Y, YS equal to CS. Okay, so the step 2 is structure for block diagramming. Step 2.1, substantial YS equal to CS into the equation for CS, and you can see the function. And step 2.2, substitute E equal to X, and step 2.3, rearrange it to show feedback loop structure. And step 3 is constructing the block diagram step by step. Step 3.1, input and the zero pass. The input single X directly connect to the zero single X single ES, forming the initial pass. And step 3.2, forward pass disturbance. E passes through G, and its output is summed with the disturbance signal N at the summation point. And step 3.3, feedback loop. Output Y is feedback through H and subtracted at the summation point, closing the feedback loop. And step 3, final equivalent block diagram. This is complete structure that integrates the input, forward pass, disturbance, and feedback loop, directly equivalent to the original signal flow graph. It accurately responds all signal flows, and the relationships include x, n, g, h, and y. And step 4, verification of equivalence from SFG, you can see, and from block diagram. Both methods yield the identical transfer function, confirming the equivalence of the SFG and the block diagram. Okay, so you can see the summarize. You can see the list about feature, signal flow graph, and the block diagram. The equivalence between the signal flow graph and the block diagram has been successfully demonstrated through equation extraction, diagram construction, and transfer function. This process confirms that both tools are valid and interchangeable for modeling linear control system, fulfilling the experiment objectives. Okay, so that's all. Thank you for listening.